Good afternoon. My name is Luis Flores.
I'm Mohammad Al-Saik.
And I'm Marshall Motley.
The purpose of this video is to help you understand how to design a 12-foot simply supported southern pine #1 column with a dead load of 1,500 pounds, live loads of 1,700 pounds, and a SL of 2,200 pounds. Like I mentioned already, the column is going to be 12 foot, and the givens are listed as well. And we made some assumptions when we looked at the problem. We stated that CM, CT, CI, CFU are all equal to 1. So with that being said, the next step is going to be to find our design values. As you can see, we have several equations here that were all gathered from the book. And there's going to be one that's going to dominate, that's going to pretty much drive what lambda is going to be equal to. And as you can see, 6170 pounds is dominant, which is equal to 0.8. And the next steps is going to be finding the other unknowns. And as you can see, FC parallel is going to be equal to 1,150. And all these numbers are gathered from tables from the book, like I mentioned before.
And they were all directed directly to the southern pine.
The next step is going to be to find your FC star, C parallel, and as you can see, the formula is listed right here. So once we gather all of our numbers, it's just a plug and chug, and the number is going to be 3,197 psi. The next steps are going to be to find your E min, which can be defined by E min times fine and KF, and that number is listed here. Mo is going to continue and explain how to do the choose a trial step.
Okay, so after getting all of the required design values, we have to choose a trial. Before we try a member, we have to find the area required. The area required we got is 1.93 inches squared. So in class we had 4x4. We tried 4x4 and it didn't work either. So we doubled it. We got the area for 4x8, and from the book, the B is 3.5 because we have 4, and the D is 7.25 because we have 8, and that's from the book in table B1. After that, we have to check the slenderness ratio. It's going to be KL over D. We got 19.86. It has to be less than 50 to be okay, and we got that, so we're good. So now Marshall is going to talk about the stability factor.
So like Mohammad and Luis had said initially, we had to find out this column stability factor for a southern pine, and we had a 12-foot tall column. So if you look down here at our FCEN, we had a given value of 0.822 and our E prime min that we had found out earlier in our problem. So after we put that all over our slenderness ratio, like Mohammad had mentioned, we came out with a number of 1,933 psi. So after we did that, we found our big B, and then we threw that equal to our FCN over our F star C parallel. After we found this number, we came out with our 0.605, and then that actually came down and was plugged into our column stability factor given formula. So in this, we basically repeated a lot of steps that were given to us in the formula, and if you look here, you can see every step that we had taken. And down here we got 0.503, and then we checked our value for our 4x8 member, and we compared it to what our area required was to what we had found through our formula. So if you take a look here, our area required that we found was 3.837 inches squared, and in the book we have an area given of 25.375 inches squared. This is a major overkill on the member itself, and we think that after iteration we can find a value engineered member, but based on this we know we can move down from 4x8 but stay above 4x4. So in the end, thank you very much for taking the time to watch our video, and thank you for giving us the opportunity to go for this extra credit. And with that being said, see you soon.